Hi everyone. Now spanning trees. Here we have two definitions. Both are saying same. And a spanning tree is a subgraph, undirected connected graph. And your spanning tree must be non-cyclic subgraph. If a vertex is missed, then it is not a spanning tree. That means spanning tree contains n vertices, where n is the number of vertices in the given graph. Okay, and the spanning tree cannot have any cycles, and it consists of n-1 edges. Hence finally we have 3 steps. It should have n vertices. It should have n-1 edges, and finally it should have no cycles. Okay, so these 3 points are very important. N vertices should have, n-1 should have, n-1 edges should have, and no cycles. Okay, now a graph G can have multiple spanning trees. Let us check with this example. So this is a given graph. How many vertices? 4 vertices. Yes, I took 4 vertices in spanning tree. This is my spanning tree. This is given G, right? So I am taking the edges A to B, B to C, C to D. Yes, now check how many vertices. 4 vertices. Yes, how many edges we should have? n-1, hence 4-1, 3 edges we have. And is there any cycles? No, hence it is one of the spanning tree of the given graph. And the next one, so I am taking 4 vertices here. This is A, B, C, D. So I am taking the edges 1, 2, 3. Here 4 vertices I have, n-1 edges and no cycles. Hence this is the second spanning tree. And the third one, I am taking 4 vertices, hence this is A, this is B, C, D. So I am taking the edges here, A to D, D to C, C to B. In this n vertices I have n-1 edges and no cycles. So like that we have multiple spanning trees for the given graph. Okay, now edges may or may not have weights assigned to them. See, just now we have seen this is a given graph, without edges, without weights, right? So weights may have or may not have in spanning trees. Now total number of spanning trees with n vertices that can be created from a complete graph is n to the power of n-2. Here this point saying, if you take a complete graph like this, complete graph. Yes, this is a complete graph. If you have the given graph is a complete graph, how many number of spanning trees are possible? Here n to the power of n minus 2, where n is the number of vertices in the given graph. Hence here 4 vertices, 4 minus 2, 2, and 16 spanning trees are possible for this graph. Okay, if the given graph is a complete graph. For example, if the given graph is a cycle graph, like 1, 2, 3, 4, yes, 4 vertices, and this is a cycle graph. This is this is C4. Okay, so if the given graph is a cycle graph, what is here n? 4, right? 4 vertices. N number of spanning trees are possible. If it is C3, what is n here? 3, right? So 3 spanning trees are possible. If it is C5, what is n here? Number of vertices, how many number of vertices here? 5. Hence 5 spanning trees are possible for cycle graph. And we have 2 points over here. If it is the complete graph, we should have n to the power of n minus 2 spanning trees. If we have cycle graph, we have n spanning trees. Okay, n spanning trees, where n is the number of vertices in the given cycle graph. Now minimum spanning trees. So just now we have seen one point, a graph G can have multiple spanning trees. Among multiple spanning trees, we need to find which is the minimum one. So that process we call it as minimum spanning trees. Okay, and here minimum spanning tree, the one which contain least weight among all other spanning trees. Okay, so to do minimum spanning trees, we have famous algorithms like Prim's and Krushkal algorithm. Let us see one by one with example. Now Krushkal algorithm. Krushkal algorithm is to find minimum cost spanning tree using greedy approach. An input of this algorithm is weighted, connected and directed graph. I think you know what are these weighted, connected and directed graph. And output of this algorithm is minimum cost spanning tree. Okay, and these are the 5 steps we have under Krushkal algorithm. First step is very important. If any loops or parallel edges in given graph, please remove them first. Okay, remove all loops and parallel edges first. If no loops and no parallel edges like this graph, you can start from second step onwards. But if any loop parallel edges like this, loops like this, you should remove all the loops and parallel edges first. Then you can start actual procedure. Okay, so remember the first point is very important. Now choose an edge u comma v from E. E is the set of edges in the given graph. From that set of edges, you can choose any edge which is lowest cost, and delete edge u comma v from E. And if u comma v does not create a cycle, then add in u comma v to T. Here T is your spanning tree, otherwise discard it. If that edge is not forming a cycle, then add in T, otherwise discard it. Until T contains n minus 1 edges, repeat this process. Repeat this second step, third step and fourth step. Repeat 2, 3, 4 steps until T contains n minus 1 edges. Okay, so let us see one example, you will be clear. Okay, this is the given graph. First check, is there any loops or parallel edges? No. Then starts with the second step, and before that take all edges in E set and take initially T is empty. here T is your spanning tree and E is your given graph edges set, and this table indicates your edge respective cost. And here why 1 to 5 only? Because the given graph having 1 to 6 and 6 vertices in spanning tree, n minus 1 edges, that's why 1 to 5 I wrote. Okay, so first take like this the vertices as it is, like given graph without edges, right? So what is the second step? Choose the least cost from the set of edges. So which is the edge having least cost? 1 to 4, right? So 1 to 4, take 1 to 4 like this, and 1 to 4 not forming a cycle, then remove from E and add in first edge along with the cost, okay, and add in T. Okay, so here cost is 1. So next least cost is 1 to 2, that is 2, right? So here 1 to 2 with cost 2, and 1 to 2 is not forming a cycle, that's why eliminating from E and adding in T and taking 1 to edge along with cost. Okay, next least cost is, we have two choice here, 2 to 4 and 2 to 3. If I take 2 to 4 cycle formation, if I take 2 to 4 cycle formation, then discard it, then 2 to 3 is possible, right? So edge is 2 to 3 with cost 3, and 2 to 3 is not forming a cycle, then remove from E and adding in T and taking 2, 3 as third edge with cost 3. Now next list is 4, 1 to 5. So 1 to 5 like this with cost 4. So 1 to 5 not forming a cycle, then 1 to 5 is removing from E and adding to T and taking as fourth edge with cost 4. Okay, now next least edge is 5. So if I take 5 cycle formation, then discard it. Next 7 I have, yes, 2 to 7 not forming a cycle, so 2 to 7 with cost 7. So 2 to 6, 2 to 6 is not forming a cycle, then remove from E and add in T, then take as fifth edge with cost. Hence n minus 1 edges we have in T, then stop the process. So check this, how many vertices? 6 vertices, same as given graph. How many edges? 1, 2, 3, 4, 5, n minus 1 edges. Is there any cycles in this? No. Then this is your spanning tree, but we need to minimum spanning tree, right? So then add the total. So 1 plus 2 plus 3 plus 4 plus 7. So here 7, 10, 17, right? So 17 is the minimum cost spanning tree. So this is about Krushkal algorithm. Yeah, next Prim's algorithm. Here Prim's algorithm is used to find minimum spanning tree of the given graph with greedy approach, and here Krushkal and Prim's algorithms are both are under greedy approach only, and input of Prim's algorithm is same as Krushkal, weighted, connected, undirected graph, and output is also same as the Krushkal algorithm, minimum cost spanning tree. Okay, and here you should understood the steps for Prim's algorithm. The first step is, as usual, the Krushkal algorithm, remove all loops and parallel edges. And here in Krushkal algorithm we are selecting an edge from edge set which is minimum or which is least cost, whereas Prim's algorithm we are selecting a vertex randomly. You can pick any vertex randomly, right? Then check edge and select the one with less cost, and delete edge u comma v from e, and if that u comma v is forming a cycle, discard it, otherwise add it. Then if t contains n minus 1 edges, then stop it. So here 4th, 5th, 6th step is same as the Krushkal, and 2 and 3 are different. Okay, so here second step, randomly choose any vertex from the given graph, right? From that vertex you need to pick less cost. Okay, so I will explain with one example, you will be clear. So here the given graph with no loops and no parallel edges. Then second step, choose one vertex randomly, hence I am choosing one is my chosen vertex. Then from 1 I have 1 to 2 and 1 to 6 edges. So 1 to 2 is 28 and 1 to 6 is 10. So which is the least one? 1 to 6. So here 1 to 6 is removing. Then I am adding 1 6 and I am taking 1 6 as the first edge with 10 cost. And we should take the vertices as given graph without edges first. Then I chosen 1, right? So from 1 to 6 is our least edge with cost 10. Okay, next from 6 25 I have, from 1 28, from 1 to 2 28, and 6 to 5 25. Which is the least? 25 is the least, right? So I am choosing 6 to 5, which is 25. Okay, hence 6 to 5 is not forming a cycle, so 6 to 5 or 5 to 6, whatever. Hence I am removing from E and I am adding 6 5, and I am taking second edge as 6 5 with cost 25. Okay, now I am at 5. From 5 I have 5 to 7 24, 5 to 4 22, and 1 to 2 28. Which is the least? 28 24 22. 22 is the least, right? Hence 5 to 4 is the least cost with the 22, right? So here 5 to 4 is not forming a cycle, hence I am removing from E and I am adding in T, and I am taking 5 4 as third edge with the 22 cost. Now I am at 4. From 4 I have 4 to 7, 4 to 3, and from 5 to 7, and from 1 to 2. So which is the least? 28, 24, 18, 12. So 12 is the least, right? Hence 4 to 3, 12. And here 4 to 3 is not forming a cycle. Then I am removing from E and I am adding in T, and I am taking 3 4 as fourth edge with cost 12, right? So here 4 to Now I'm at 3. From 3 to 2 is there, and from 4 to 7 is there. Okay, then from 5 to 7 is there, and from 1 to 2 is there. 28, 24, 18, 16, which is the least? 16 is the least, right? Hence 3 to 2 with 16 cost. Okay, so here 3 to 2 is not forming a cycle. Then I am removing from E and I am adding in T, and I am taking 2 3 as fifth edge with 16 cost. Now I am at 2. From 2 to 1 is there, 2 to 7 is there, and from 4 to 7 is there, from 5 to 7 is there. So which is the least? 28, 14, 18, 24. 14 is the least, right? 2 to 7. Hence I am taking 2 to 7 with 14, and 2 to 7 is not forming a cycle. Then 2 to 7, removing from E, and I am adding in T, and I am taking as the sixth vertex 2 to 7 with cost 14, right? Hence no more edges required. Hence n-1 edges are over. In T, n-1 edges, then stop. Once all edges are over, then calculate the total cost. 10 plus 25 plus 22 plus 12 plus 16 plus 14, then it is 99. Okay, so now check here how many vertices. Same as the given vertex set, 1 to 7. N vertices are there, and 6 edges, that means n-1 edges, and there is no cycles. Then this is your spanning tree. Minimum cost spanning tree. Minimum cost spanning tree. So this is a way to do spanning trees from the given graph with Prim's algorithm. I hope everyone understood Prim's algorithm and Krushkal algorithm. Thank you.